rack coming in, and so we were in the data center. So now we have our connectivity again, and so we're ready to pull the high speed into our lab. Several switches and but anyway.
Professor, we were just joking since Ibrahim is at school. If you didn't come to the meeting, he was going to come knock on your door.
Yeah, I was wondering, but I just look at the senior design in the lab. I think I don't find the people there yet. But anyway, yeah. All right, so I think let's because I have another 6 o'clock meeting, so I think we better, let's get started, right?
Okay.
You may share and go on.
Yeah, let me share 1 second.
Yeah.
Professor, what days are you in the college anyways?
Well, not every day, of course not. It's it's intermittently because of the ongoing project. So whenever I need to be there, I be there. So yeah, it's not frequent. It's once in a while.
Okay, sure.
It's on here anyway.
Yeah. I saw the block diagram. I think now it's better shaped.
Okay, this is from last week, right, Hamza?
Yes,
Yep.
The meeting from last week. Yep.
Yeah, so these were the points to redo the block diagram, which Hamza emailed to you and asked about, to add Wi-Fi. That was also done. The cost of sending out the design of PCB. Do you want to talk about this now, Hamza?
Later on the slides.
Okay.
Just later.
Okay.
Okay, so we could probably move on from here. So this is from last week, the summary and the things to do.
Yep.
So this is our new block diagram, which you already had a chance to look at.
Yeah, I think I see that. Yeah,
it's good. Yeah, everything you said, I added.
It's better made now.
Yes. Yeah.
Yeah. Okay. But you don't use the Bluetooth, right?
We don't use the Bluetooth yet.
So all the communication is done
through Wi-Fi.
Okay. All right. Good.
Okay. I'm just pulling out something to take notes with.
So like you said, include the Wi-Fi into the diagram. I did that. And you said
yeah.
And make sure to show the connections. They're done through dotted lines. You asked me to do that, and you in the email said include the smartphone. I did that. Added that to the diagram too. So overall, you can see we have PC and then the smart home controller and Raspberry Pi. You can see the all physical layer of the components that will be for the project.
Okay.
So yeah, you can go to the next slide.
Here is the cost of our PCB board. So I have done some research on some companies, and it turns out to be like more. It's going to be produced in China. So it's two very famous companies, which is PCBWay. Another one is GLCP PCB. The PCB board is the PCBWay. They're going to take our order, our design, and they're going to produce it. And the cost is going to be $5 for 10 pieces of our PCB board. So then the other one is GLC PCB board, which is $2 for 5 pieces. And I'm trying to make myself happy, just going to pick one of them, and I'm undecided so far. So maybe I need one more week to go with the quality of which one is good and which one has more lenient, and how long it's going to take to get the PCB board. And once we get the PCB board, so what we do is, like, as I put over there, is like optional, so to assembly, and it's $30 to give to a professional company to assemble it. meaning like the electronic components on our PCB board, like soldering. But as I have enough experience in a soldering section, so I could do it myself. I mean, it's not going to be perfect as the companies, but I try my best to do it. And
I think making everything of
clean and neat.
not a good idea.
Yeah.
I mean the soldering is.
So those companies, how long is it going to take to manufacture the product? It takes 24 hours to 3 days. Maximum is 3 days, and it takes 3 days to 1 week to ship to the States. It's
all the way from China.
All the way from
all
China.
the way
Yep.
from China. Mm-hmm.
Wow. So they use the air shipping, I think, right?
The air shipping, yes. They use
because it's 10 PCB is very small, I guess. Very small.
right. It's just very small.
Okay.
And the total is under $50. And let me share my my part, what I have done here. So I'm gonna be showing you some schematic and some 2D, 3D.
Yeah, Professor. Let me just add one more comment that if we use American companies to make this, they would charge us like hundreds of dollars. More than $100 just to make PCB board. So we using China
and
to
China
make it cheap. Make it cheap and good.
It's a great option.
Yeah.
In this way.
But I think, make sure that before order, whether they really ship in as discussed here, right?
They do. Yes, they do.
Mm-hmm, they do.
Okay.
They do
Yeah.
ship
So
to the States.
just make sure when you order, right? Make sure that the delivery is, so that you can do it, reasonable amount of time.
Sure.
Right. Wasim, can you
unshare,
please? So here, I gotta go to desktop. Let me start from here. Here we go. Let me start from here. So as you see on the screen, you see so many wires, and it's extremely, how would I put it? It's extremely going here and there, and it makes you super confused. Let me start from the bottom of our PCB board. So the PCB board itself has it has so many electronic components, and the PCB board is actually 3 by 3 centimeters.
Yeah.
So as you see, like the purple line around it, and from that as you see here, and these 4 is just connectors, and on the top of the connectors are relays. As you see here, these are 4 relays. On the top of the relays are galvanic isolations. As you see here, these parts, right? Every relay has galvanic part. So as you see here, and here and here, this is 4 of them.
So just a second. So the relay, do you really consider the relay dimension and height and
Yes. So what I do is definitely
to make enough space.
Yeah,
right?
Definitely I will go more in detail in a coming week, and then I need time to be done with this PCB board. Definitely I will show you that.
I think especially is important to
I did very precise estimation.
Yeah, so that make enough space to
put enough,
touch the next one.
Yeah, put up enough. Yeah, you will see it. So,
okay.
So
and also this the PCB pattern, right? Don't you have this routing, the kappa path routing?
But basically it does itself, but it's not perfect. So that's why it's much better to use it like manually, because it's not perfect at all. I mean the routing, you're talking about the routing.
Yeah, routing, let's say from the one of the point on the right connector and coming into, you know, how it is all this connectivity is done, right?
And
Using the
understood your point.
Yeah,
but it's not, you know, if something is done by manually, like it's much better and valuable. You could, you know, put like in precise point.
That I don't know whether the manual is better than
I mean
auto routing, right?
The auto routing, yeah, but in this case the auto routing is terrible.
Yeah. Because you are using the free software.
Yeah, it's software. It's online software.
I don't know.
Yeah, it's a very good software. You see here on the top of our PCB board, it's ESP32.
Yeah.
It's not finalized position, but we could have moved it here and there, and that's not the right position so far. I mean, we could move it here and there.
So do you have any snapshot of the routing?
You could show, I mean, we could show the 2D model, 3D model.
So sure. Let me
Yeah.
go. Then let me. So let me go here and then. And here's the 2D.
But it doesn't show the exact routing. I mean the path, copper path.
Yeah. It will. You know, I will come. I will come to that. It does show, but it's not. You know, it's not perfect. As I said, you know, manually is much better. It takes time, but you know, as you said, like the auto routing, it uses, but it's not preferably recommended.
Sometimes it's hard to without crossing over. It's a planar graph, I think. Right?
Yeah, that's why that's the problem.
Yeah, it doesn't.
It intersects and it make a mess. So that's why.
So
that's why the auto routing is not it's not recommended.
But if you're using like a multi-layer, like 3 layers.
Yes, this is our PCB board is designed in 2 layers.
So the surface layer, right? And then
this is the top layer has most of the
the path
and tracks, stuff like that. But the bottom one is more the power.
Like going over, right?
Just in going over the power. So we don't really touch the bottom part because it's dangerous. So we don't want to damage our circuit. This is the 2D. As I mentioned here, this is I square C, and this
and also, don't you have like a 4 corners drill, and maybe it's just not on the bottom, maybe it just stand itself, like you put the 4 corners, right?
You
put so that you can make a like away from the bottom space, like
I think we're gonna have a case for the PCB board.
Yes,
that's
we're gonna be
3D printed.
building 3D case. Yep, for this.
Then still you don't put this PCB, put the bottom, right? It should be like this, so that you have a 4 corners screw, like whatchamacallit the.
Oh, okay. I see what you mean. You in the 4 corners we had to.
Yeah, 4 corners, so that you have a like
to attach some places.
Yeah, so that it stands itself.
Okay.
When you are designing the cover, this 4 corners like this sticking out, so the cover goes.
It's a good idea.
Yeah.
I will take
so just add that. Yeah.
Definitely. Yeah. Thanks for that.
Because we bought a small module that has this.
So and here's the 3D part of the circuit. So as you see here, this is the like the inputs, and you see here like these 4 relays, and these are 4 connectors, and this you see here like all those components, electronic components, the I2C, and this is our chip, ESP32 ROM.
Does the relay have the power concentration, the heating there? So if there's a lot of heating coming out, maybe you
There
may
we go.
wanna
So
spread-
that's why we don't want to put so many components from the middle of this part. We don't want to put down there because it's as you said, like it's not safe.
Then I think what I'm saying is that maybe you may want to separate these 4 relays, like so spread out.
No. I mean, I understood your point. Still,
Okay.
like, you know, if I put it, like, for example, if I put it in a different corners, all these relays.
Yeah,
so-
for example. Yeah, for example. Yeah.
For example, yeah. But it's not safe because what happened is, like, under this, it's a power, and the power is going to damage other components.
But you still your other components are right above the
Yeah, like it's so far it's a well positioned component so far. I mean, as you see, like I think I had like whatever I see, like the module, it's always the relay drivers are next to each other.
Oh yeah, okay.
Yes.
Yeah, if you
always.
see the good example, I think.
Yeah. So
okay.
let me see if I have it in my like I think I don't have it in my background because no, unfortunately I don't have it.
Okay.
Yeah.
But I just be sure that you may want to take a look at other who have multiple relays and how
Right.
they distribute it. So
Yeah.
I think the only thing is that to me is a heating. So maybe you may want to spread out together with a connector. So the each connector have like a two in the right hand side and 2 in the left hand side, and all the small electronic components are in the sort of in the middle. I don't know whether that is so you see what I'm saying,
Yeah,
right?
yeah,
So
yeah. I
try
see
to
what you
disperse
Okay.
in the consideration of the heat thing and so on. So just look at the other designs which have this relay in it, so that whether that is in a good approach or not.
Yes, in this case, as you said before, like these inputs were inside, but you know, as I say, it's just a learning process, and also it's just not finalized one. So we could, you know, move here and there. As you see, like the whole thing was down there. Then I moved up to here, and then
I see.
yeah, and then it's just step by step process. And this is I square C, but it's still like the I square C and the ESP32 before I square. I mean, ESP32 was we could change anytime. We could move it anytime to some other place. But as I mentioned for the relays, as I mentioned, it's like sort of standard. So we put all the relays or in a one position next to each other. That's more safe. And as you see, like I will show you in 3D and 2D that you might have a better understanding of this project.
Layout, yeah.
Yes. So, yeah. And so as you see here, like I make a just tracking. You see here, Professor, like it's just tracking this part. You see, it's just one part, and this is our relay, and this is the galvanic parts.
Yeah.
You see here, and this is the same thing. This is another part, because the galvanic part is just, you know, controlling the relay, and the same thing here and 4 of our relays. And this is I square C, and still my ESP32 is down there. And
by the way, so now I see that the wire the path, right?
The path, yeah, the track
from the connector to the components going next to the relay.
Yes.
This long, you traced it. And so when the relay on and off, there might be some sparks which generate the noisy signal that noise may get into this PCB path?
I'm not sure. So
Yeah, we are not sure, but so I
I
think
will
the
do
best
more
bet is
research,
that,
and then I will do more studying about this, and then maybe the coming week, definitely I will come up with
yeah.
the
So
solution.
what I'm saying is that like this. So connector here, and so the connector to the relay should be just a very short the kappa path. Otherwise, this one generate. I mean, it is no secret that relay is on and off, right?
On and off, yeah, it's controlled by the galvanic part.
Because it's a high voltage on and off, right?
Right.
High voltage on and off. So that might generate a spark, which impacts because it's a high voltage, and the other circuit is operating, like 3 volts, right?
Right.
That easily contaminate or because I'm teaching the communication, so it is easy get into it because the path, the kappa path works as a antenna. So it gets into this path. So the design, I hope that you are avoiding as much as possible of. So my suggestion is, one side is a relay, and the other side, this side is electronic. So the last part of the electronic come into the thing.
Yeah, that's exactly what I do. I try to put more the electronics on top of the.
But the one wire, as you see, that one wire is going pass through the here, the connector, pass through the relay.
It's not wire. It's just this is a track, so I want to show you. It's just indication. It's just not wire.
So this so there is no
yeah, that one is not wire. Just it's a track, and to show you like this is the galvanic part to control the relay.
Okay, so the relay output is going to the connector, right?
Right.
Okay, so
yeah, this is a connector. Yep. Yeah. And then and as you say, like I don't have much components because here you see like later on I'm not gonna be putting components down here and here because it's not safe. Not
only the component like the path,
and
right? The path
like,
doesn't go.
I haven't done so much of it. It's just in the process, and then I'm gonna put more components around this PC board. Let's go to the next one, please.
So just a second.
Yeah.
Yeah. So I think
this is the 3D.
So consider try to separate the electromagnetically separate the relay from the rest of the circuit. Right.
I went to the robotics lab, and then I saw the some relay drivers modules. So when I saw it, it's just most of them are like in the way they are designed, the way they are set it up, or like it's next to each other, and the electronic components are on top of the
but that does not justify, right? Robotics people do this, but this is more on the like interference.
I mean, whenever I saw it, like it's more good.
So maybe I think okay, I want you to study again Google like relay what is the best the routing PCB technique, relay and other electronic components or something like that. That hopefully that might turn up some idea, right?
Right.
Yeah, but I think obviously I see that the relay generates a spike, and somehow I think that is one thing you may want to consider, right? I mean, so when do you expect to complete this one? But I think that here is the one thing that is very difficult to make a decision, because unless you finish it, it's hard to test, right? There's no way of testing this thing before you send out and make the PCB and order the components and put together, and then only then you will be able to see whether.
Yeah, I like that. I like the way you say like it's hard to test it, and then it's gonna be,
But it will take some time. So I think what I'm saying is that
I try my best to finish up as soon as possible.
spend more time in early on. That makes later on save the investment.
I mean, it's a great it's a great software. We use it, and I know so much stuff about electronic components and how to place it. I mean, how to pick up and just realize the functionality of the components and how it works, to be honest, and so on. It's a great software.
All right, so sure, right? So I
love it.
Around this, study more before
like
finalizing it.
Sure.
Okay, good.
Sure.
All right, move on. Yeah, go on.
You're on mute, by the way. Whose part is this? Hassan?
Over.
Wasim, you're on mute, I think.
Oh, sorry, I was on mute. I was talking. Yeah, okay, so moving on, we're talking about the Mosquito server, which is the lightweight protocol that we're using to send signals to and from the Android device. We specifically went with this because it's a lightweight broker as opposed to the other ones that have a lot of overhead and may cause delay. This also is open source, so we're able to access it easily and able to use it freely.
Yep.
So just a little bit about that. So, I mean, as I mentioned, it is going to be our way of carrying out the messaging system to publish and subscribe from a topic or model that we choose. To look at the interface a little bit. So this is from MQTT Lens, which is also an extension. It's not an extension, it's an application that I downloaded on my Mac. And then there's also an extension on Chrome, which so first I homebrew installed the Mosquito server. And then this MQTT is an application that I installed on my Mac. So it allows us to create a connection. It allows us to input an IP address, and then you're able to create a secure connection. You can put a username and password so it can't be accessed by anyone, because one downside to using the MQTT protocol is that anyone that's able to log in is then able to, and if you could have no username or password, so they could just find your connection. They would be able to log in and send whatever commands or publish anything to your topics. To look at that connection. To look at that connection a little bit more, this is kind of how that screen is on MQTT Lens, the application I downloaded. You're able to have a topic, and then you're able to subscribe. You're able to create that topic many times and send whatever signal you'd like. So for our system, in a home automation system, how this would be useful is we can pick up relays and we can send signals based off, for instance, a temperature. For instance, if we detect there's multiple people in a room, we would be able to send that message to a topic. So for instance, it would say 5 people have entered the room. It would use motion detection, whatever scenario we're planning for. So like 5 people are in the living room. So it would send that message to a certain topic, it would publish it. And then based off that, we would then have some computer logic in place. Based off this scenario, another action would then happen. So that's one way of using this that we would like to do. So something that I still have to research here, I still have to build the connection with the Android device. This so far is just in theory. I still have to establish the actual connection. And then with the user interface I showed 2 weeks ago, I want to be like, I'm still trying to figure out how I can actually send messages here. So it changes something on the Android device phone and it's actually able to perform commands that way. So that's something I'm looking
So
into.
that's through the Wi-Fi link. Right?
Yes.
Okay.
So I would have to connect my phone as well to this protocol so that they're able to talk to each other. And then when these commands are happening over here and like different messages are being populated on this end, the Android device is able to pick it up and then perform a command accordingly.
So which one serves as the server and which one is going to be client?
Well, I mean, it's going to be on a Mosquito server.
Where the like a physical device? Which device that this Mosquito server will residing?
So
or Raspberry
it
Pi?
will be from a PC connection, and then it's going to be translated over to the phone. So it is going to have to go through that intermediate PC connection, but like it's going to be connected wirelessly. So this is just going to live on the PC, but it's not, you know, it's not a hardwired connection in that sense.
So later on, okay, so again, so it's a part of the system. The PC is a part of the system. That's really
Yeah. And that's only because for the Mac environment specifically, to run the Mosquito server, I need to have it continuously on and running. I believe for Windows, it is different. I don't need to have it consistently running on my terminal, which is the current Mac process. So it's consistently running. It's consistently generating that connection on my terminal. And then I'm able to send commands back and forth. And then this is able to run and publish messages. So for that part, yeah, my PC would be necessary.
So I think we talk about this. So will you have this display, separate display and based on this Raspberry Pi or some, or
So
you know, the home control, let's say home control, which one will be used as a home control?
So the end user is only going to have their mobile device. There's no need for them to see the MQTT part of it, of all these messages being sent back and forth. So they would just have their mobile device that either receives notifications or they're able to perform commands from there.
So at home, the notebook has to be always there.
So for Mac, it does have to be active because the server needs to be running on the terminal. For Windows, I don't believe that's the case. For Windows, I believe it's just a Wi-Fi connection and it's able to run from anywhere.
So I think that the Mac window, I think it doesn't matter. So that's why I was asking because you know, as I said, you know, some other people are using the MQTT, but without having a PC, you know, PC. So the Raspberry Pi can be the server, and you know,
Okay.
mobile phone could be the client, you know, or the other way around. I think MQTT server will, you know, I think publish, and then it can connect to you know, multiple devices, or you know, from the Raspberry Pi it will be the MQTT server sitting there, and you know, client is a mobile device, and maybe other, you know, the sensors. So that's how you do it. Can you go back to the the block diagram of the system? Yeah, here. So here I see, I expect that this is a Linux smart home controller. That's a Linux, and then Raspberry Pi. Oh, okay, here. Yeah, maybe here, Raspberry Pi, and that can be because I saw the, you know, and then you just, you know, search the, you know, GitHub or whatever open source, and the Raspberry Pi is running this Linux. And it have TensorFlow and OpenCV, everything, and plus, you know, this MQTT server, which I think doesn't occupy that much. So MQTT servers stay there, and then communicating with the home controller and communicating with the smartphone. I think that should be the way, to my mind. What do you think?
So you're saying we're missing a portion for the PC?
Yeah, so I think that, yeah, we may not, initially when you develop it, you might have it, but I think it is eventually MQTT server stays, MQTT server and clients are everywhere, right? Let's say this, at the moment, maybe forget about the PC, and then home, smart home, and, home controller, Raspberry Pi, and smartphone. These three will be connected by this MQTT protocol communication among this.
I don't think that's necessarily true, because the home assistant can also take and give commands from the Raspberry Pi. It can also pick up. I think I think there's multiple ways to receive and give commands.
Because I remember that I told you that, IoT here, the home controller thing have the processor in it, and also Raspberry Pi, there are two processors, two computers already there. And involving this PC, I don't know whether that is really necessary.
I think it's more so, like we discussed before, it's more so for the use of space memory-wise, that it might not, the Raspberry Pi or the other devices might not be able to handle it, which is why we're incorporating the PC. But of course, that's still, like, after we have everything on there, then we would really be able to tell. And I think Hassan can speak to that.
Okay. Yeah, so I think, all right. So when you develop it, it's just have the good experience from this PC, and then
Professor, if I'm wrong, please correct me. So as you said, we have already two
computers, right?
Yeah, like basically two computers down there. I mean, instead of Raspberry Pi, isn't it be good to use ESP32, because ESP32 is way cheaper than a Raspberry Pi and it does the same work?
I think it can, but I think I don't know. All the nice Linux servers and everything is out there already, right? All those open sources out there for Raspberry Pi. I don't know how that bodes well in the ESP32, but I think either way it works. I think that they are using the same processor, ARM processor. I think. Yeah, so I think it's doable, and then also as you see here, the Raspberry Pi in this case using the Linux, and everything is I think a Linux operating system, not the Windows. Windows is not going to be fitting to the Raspberry Pi or ESP32. So it's very simple Raspberry the Linux there. So I think that's what I think I have been talking about. So it is okay for you to develop this for some time, and then if you have more, firm grip on this handling this Raspberry Pi and then ESP32, then I think may be able to port the work that you did in the PC to either Raspberry Pi or ESP32, I think.
Okay.
Okay, we will try
because
work on
so
it.
I already saw that at MQTT servers are working with Raspberry Pis and so on. So it is there. I'm sure that it can be done without using the PC.
So, I mean, yeah, but I think there were, maybe I'm forgetting. I believe there were more reasons we needed the PC, but I can make a note.
Maybe I think that home assistant software package, I guess, that might be.
Yeah, I do believe it was a memory space issue, and the thing is, if we're already using a PC, it might be less strain on a Raspberry Pi or on the ESP32 to just incorporate the PC, which would definitely have the most power.
Then, yeah, I know, but see, think about this. So this is the home controller system you sell, I mean, as a product, right? People may,
Mhm.
well, then you're saying, are you suggesting that then user need to buy the notebook? You know,
No,
yeah, so
that's true.
that's the question that we have to answer. And toward the end, definitely, people will ask. I don't know whether the Mr. Borin already asked this question. So, but it's doable because people do it. So I think it's doable, but it's a matter. So I think you may want to look into more. So Home Assistant, because how many features that you're gonna use from the Home Assistant software package. If it's maybe several, like 2 or 3 functions there, then I think you can just write the function on the Pi side as well.
Okay.
The Pi already have the intelligence there, right? OpenCVs and TensorFlow is there, so that you can train, and then output will be coming from there, and then you communicate with. So let's say so somehow they detect something using the TensorFlow or something, and then using the MQTT communicating with the other board, like ESP32. And the ESP32, upon receiving this MQTT, the client, the message, and it will, convert that into some, action using the relay, is something like that, right? Or you read the current state from the certain sensors, like the sensors and other sensors. That's basically what you do.
Okay. So
Right?
Okay, we will take a look into that.
gotcha. Yeah.
Yeah.
To try to minimize the use of the PC altogether.
Yeah.
Okay.
Yeah.
Sure. Yeah.
This is Hamza.
Now this is Hassan part.
This excuse me, this is Mike. So as we talked to before, like the last meeting, I successfully installed OpenCV in my Raspberry Pi. I had some challenging to install this because I believe the Raspberry Pi, they changed their the Debian terminal. So they right now they use like a Bullseye or something like that. It's called Bullseye. So the everything is changed a little bit. The all like couple of command is not similar, and then all the libraries in still now in like the OpenCV and is like is working with like Debian Buster, the Buster terminal. So yeah, I have so much difficulty to download these things because there's a tons of like command file there, and then I don't know what I chose, and there are so many libraries to support to download this OpenCV. So, but unfortunately, I mean, yeah, I was like last night, I was like trying like whole night, and then successfully I install it. And I'm going to show you like in my terminal if you unshare this.
Yeah, sure.
Yeah, all right. So, it's frozen. Okay. You can see my terminal, right? So
yes.
I connect I connect SSL secure shell to my computer. From there I can just like show you like I mean successfully I download this OpenCV in my Raspberry Pi. So if I type Python, it's lagging. This is the problem. Python 3. So it's import. Import to It shows like I have currently I have like 4.514 dBn. So this is the the
A
OpenCV new
DVN or
version
device?
in
Is it
my
device? Is it device or DVN?
it's a
Device.
it's the device, yeah.
No?
Sorry.
Yeah.
Yeah, it's a deb is device, yeah. So this is the right now in sitting in my Raspberry Pi. So the furthermore, I need to have a like camera. So for that to actually is how it's working, and from there I can go like furthermore, and I also wrote some Python script, and then also try to gather more knowledge how is the OpenCV work.
So you
And
have a
then
camera received?
no, I don't have a camera. I'm waiting for the camera because you said last week you have some spare camera in your office, right? If you have something, lend it to me.
Well, but I think you may want to go ahead and buy it.
Okay, no problem. Yeah, so we need to. So we need to buy a camera for check this. And okay, I unshared this. Can you share this?
Only if I remembered, then I could have put something. But
Professor, you were showing last time you had like couple 2, 3 in the office.
yeah, I think I have a couple of, at least I think 2, but I don't know.
Okay, we'll buy one for no.
Okay, so yeah.
How much was it?
It's not that much.
I think it's like $10,
$9.
But the problem is like the shipping. They charge you for shipping,
because I have to ship it and I go to school, and I think you better buy it.
Yeah, sure, no problem.
It's okay, no problem.
If I remember today, I could have brought it, but I think it's okay. Yeah, buy it.
It's okay, never mind. Okay.
And then so as I mentioned, like the Python 3 programming, I'm working with the develop the scenario for human recognition and this project. So we discussed before the meeting, and our group, like they said, like, so the scenario of the project is the OpenCV, like human face recognition, and this like last meeting we also discussed about the automatic door lock. When you just like the system is recognize your face as door is open automatically, and then you send the notification to the owner's smartphone through the MQTT client server. So this part is working in Wasim. So yeah, as we mentioned, like so he working with this thing in the computer. So and the professor you want to this thing is working on like the Raspberry Pi. Yeah. So I believe like this is the more convenient way to if we transfer to MQTT software or broker in Raspberry Pi. I think so that's more convenient to like I mean control the like everything from.
Yeah, imagine you are making a company and then you sell this product.
Yeah.
So that regarding that, there is a question. So for the presentation aspect of it, I mean, we wouldn't be able to have an entire door, of course. So like what would be acceptable to show locking and unlocking of a device?
Yeah. So in this case, I have in mind, I have some mind. So there is something called like the solenoid door lock. It's like a 12 bolt, like it has a like stepper motor on it.
Can you show a photo from Google?
Oh, I mean, hold on.
Yeah, I think a stepper motor can do the job. Mock up door, right? Push and pull. You just put like this, right? So the stepper motor control. So it's just moving in like this.
Okay, so okay.
I think that's I saw one of our students did that in the previous work. I think that's also doable.
Okay. Okay, so this thing is not that like what's it called? It's not like expensive, but this is $14. It's 12 volt DC.
Yeah, so turn this thing so that the 90 degree, right? So
yes.
And
yeah, so this we just for sake of like demonstration, we just like
Maybe
we just like
to put some panel and cut the panel and fix it to this motor, and so that they can just move. I think you devise some scenario. I think that way. You don't
okay.
do the whole, whole doors and whole house and just do that, right?
If we show like that way, like I mean, if it is recognize the face and it's like it's making like some kind of noise. I mean, the lock is going inside, and then if it's not recognized, it's going up, like it's coming out. I mean, it's making like some kind of noise.
Okay, so I think. Yeah, so I think that's a part of your scenario to design. So I think you got to design, and presentation is another thing, right? How to show all this functionality there.
Yes.
Okay. Today I don't have that much time left. Like maybe for the last 5 minutes, I think who will do it? Ansari or
No, we're good. Professor, we had a question.
okay.
Hassan needed help with the TensorFlow and Python. So do you have anybody that can help us with the TensorFlow and Python?
So at the moment, it's a running TensorFlow is you don't need anything, right?
No, Professor. No, we don't need to.
Yeah, so you don't need to. Why you need it?
I need a little help with the Python.
That's
coding.
it's a Python code.
Yeah, I need to help with the Python coding to like, because I don't have that much knowledge on it. I mean, I have the knowledge. I have knowledge. I know how to write the Python code, but the thing is like you have like some kind of logic, So for the understanding, I need help. So do you have any student for like doing that kind of stuff?
Maybe I may ask my PhD student to help you.
Okay. Okay, no problem.
Because I think previous students already graduated and went on. So I think my PhD student now is training using autoencoder, the graph neural network. So I think he did. He showed me last time, some time ago, the Python programming, showing this TensorFlow. And also, yeah, there is another guy, but he's not. I have another project team.
Yeah.
This is a real company setting, and he is not a student of City College, so I think. About this, let me see TensorFlow. Who can do the TensorFlow? But I think these guys are learned, from the videos and all that, So it's out there. It is.
Yeah, Professor, I understand what you're talking about. Because all the videos and all the libraries right now.
Yeah.
I told you before.
That's a part of your studies. That's your study.
I know.
Look, the other students already did it.
Yeah.
Only you will be able to do that. But
okay, Professor, no problem.
Yeah. Okay.
Professor, just saying that there's a new software that released this recently. That's why you need help with that TensorFlow.
No, you can do it. I mean, you guys can do it. Believe me. You believe yourself.
It's okay, Professor, no problem. Yeah.
Definitely is doable.
Yeah.
Because I'm not asking you to analyze into the TensorFlow and tweaking the TensorFlow. I'm not asking you to write the feature pre-processing thing. That is really need high level of knowledge and expertise. But this one is just as a package and use it. It's just basically it's a blind system that you just run it. To me, I think that is what it is. But try. I think you will be able to.
Yeah, no problem.
I'm sure.
Yeah.
Because you if it doesn't work, because that means that you didn't spend enough time. To me. Right. But so try like one more week. Try very hard, and if it still doesn't work, let me know. Yeah. Okay. This is the time that you learn yourself.
All right, Professor, no problem. Yeah.
Okay.
Thank you.
Yeah. What else? Today, Hamza, you did it a little bit on the Oli.
Yeah.
So. Yeah. So all right. Put the summary to the server. And all right. Yeah, sorry that today I have to another meeting at 6 o'clock, so I gotta excuse.
So,
That's okay,
Professor,
Professor.
Yeah.
regarding to your the project, and you're working on something like wireless communication, something like that.
Yeah. Well, wireless communication, in a cloud, the edge cloud, and
So,
computing, like
so you work for? I mean, you guys working for the school or just?
yeah, it's a project. It's a NSF project. So we got the several project funded by NSF.
NSF.
Yeah, and then also another one is from the working with the company.
So what does NSF stands for, Professor? If you don't mind, like what
NSF?
company is that? Yeah.
NSF is a National Science Foundation. It's a government agency.
Oh, it's a government agency.
Yeah, it's a government. It's a very toughest grant organization. US government, federal government.
So you still like you accept students
Yeah.
working in the project?
No, so this fall I accepted another PhD student. Yeah.
Only PhD students
At the moment, yes.
at the moment.
Yeah, but
Yeah.
yeah. So
We are out of that circle then.
yeah, the level of the work is a bit involved. It's part of the PhD study, but work well, and then we can consider
Also, do you have any?
some help, some help from the undergraduate students as well.
Also, do you have any?
But at the moment, I don't have any undergraduate students.
I see.
But I enjoy working with you guys. If you have a particular interested area, then of course I can talk to you more on that. Basically, we are building the future wireless testbed in the City College. That's at the same time it can support the current 5G. So we will set up several antennas, on the NEC building and the science building, and
I would love to see that.
yeah. So yeah, but the work is not started. So we send out the bidding, and so we have to select the construction guy. And these are already the part. Our counterpart is Columbia University. Columbia University had a couple of antennas set up already, and now is our turn to set up this antenna. And then afterwards, we need to test a lot of like a 6G relay, sixth generation radio, so it's IoTs and car-to-car communications and securities and edge cloud stuffs, and those things we are doing.
Yeah, sounds interesting.
Maybe I may have time to introduce what our lab is now.
Yeah, you can show us. We would love to see that.
Yeah. Okay. It's a lab itself, but what we are doing basically. Yeah.
Sure.
Okay.
So
All right. Okay. Thank you. Then
Yeah, 6 o'clock.
yeah.
We don't want to
Okay.
hold you.
So happy Thanksgiving, and
yeah.
see you in 2 weeks, right?
Okay,
Thank you. Happy Thanksgiving.
bye.
Bye. Bye.
Bye.